Hello students. So today we are going to discuss the synthesis of dibenzazepines. So now it's a tricyclic antidepressant, specifically immunostilbene derivative of tricyclic antidepressant. So when it's a dibenz, so it should consist of two benzene ring. Az stands for nitrogen and apenes means 7-membered cyclic ring. Okay, so in that way it's a tricyclic antidepressant, which is usually used for complex seizure, partial seizure, tonic-clonic seizures, and so on. Okay, now the main precursor or the main reactant for the synthesis of dibenzazepine, specifically the carbamazepine, that is 10,11 dihydro 5H dibenzazepine. Okay, so in this case, in general structural formula also we have seen that numbering will be started from this. So in that way, this is 5, 6, 7, 8, 9, and 10 and 11. Okay, so this is 10,11 dihydro 5H dibenzazepine. So this is the basic pharmacophore, or we can say it's a reactant, main reactant during the synthesis of carbamazepine. So now when this dibenzazepine is treated with the acetyl moiety, or specifically we can say acetic acid or acetic anhydride, rather the N-acetylation takes place, and then it is followed by bromosuccinamide. So when N-acetylation, it means that there must be the introduction of acetyl moiety on this nitrogen. Means this hydrogen will be replaced by acetyl moiety. So that becomes N-acetylation. And the next one is bromosuccinamide. So specifically the use of this reagent is just for the introduction or the addition of bromine moiety. Okay, so first step, the same structure like this 10,11 dihydro dibenzazepine, which is a basic reactant, that will be acted upon by N-acetylation followed by bromination, and that bromination or the addition of bromine will be taken place by this reagent, that is bromosuccinamide. So after these two steps, we are getting this structure 1. So here you can see that hydrogen in the reactant, that is replaced by acetyl moiety, and there is the introduction of bromine moiety. So this is structure 1. Now this structure 1, when again it is treated with colidine, or it is passed through the colidine and treated with ethanolic KOH, so there is the addition of double bond whenever we are using ethanolic KOH, because there are the two reagents that can be used, like aqueous KOH and ethanolic KOH. So whenever we are going to use ethanolic KOH, there is the formation of or the production of double bond. So it is assumed that here this corner represents CH2. So CH2 is present here. So specifically, there will be the elimination of HBr, and the elimination of HBr will result into the formation of this double bond, right? This is one step. And the second one, due to heating or due to passing through the colidine, so there is the removal of acetyl moiety. So again, that will become NH. Now, if you are going to compare this reactant and this structure 2, so specifically what happened? We have just introduced the double bond in this C10 and C11 position. Okay, for that, first the acetylation taken place, followed by bromosuccinamide addition. So what is the purpose of bromosuccinamide addition? Simply the addition of bromine moiety. And then after using the ethanolic KOH with the elimination of HBr, there is the introduction of double bond in the central ring. So now this structure 2 again treated with carbamoyl chloride and then phosgene. So carbamoyl chloride, in the sense, it's a simple amide functional group, and phosgene consists of this ketonic, or we can say the dichloroketonic group. So here simply there is the we can say the formation of this or replacement of this hydrogen by this amide moiety. And what is the source from where it is coming? So it is coming from this carbamoyl chloride, so that there will be the elimination of HCl, right? H from this and Cl from this. So there is the replacement of this hydrogen by C double bond O NH2. So this is how the synthesis of dibenzazepine, specifically the carbamazepine, takes place. So the first main reactant is what? 10,11 dihydro 5H dibenzazepine, which is followed by N-acetylation and then bromosuccinamide reaction. Then that will lead to the structure 1. So simply acetyl moiety will get added, and the bromine moiety will get added on the central ring. Then there is a that is acted upon by ethanolic KOH. So with the elimination of HBr, we are getting the double bond in the central ring. And now we need amide moiety because the carbamazepine consists of amide. So that hydrogen must be replaced by amide. So from where that amide is coming? So it is coming from this carbamyl chloride with the release of HCl or with the removal of HCl. So this is how the synthesis takes place.